Have you ever looked up at the night sky, gazed at the moon, and wondered, where did it come from? For centuries, this question has puzzled scientists, dreamers, and civilizations alike. The moon has inspired myths, guided ancient calendars, and even played a role in shaping scientific revolutions. But despite being our closest celestial neighbor, its origins remain one of the greatest cosmic mysteries. Was our moon once a part of Earth? Or did it come from somewhere else entirely? Welcome to Timeless Curiosity, where we explore the greatest mysteries of science, history, and the cosmos. If you love unraveling the wonders of the universe, don't forget to subscribe and join us on this incredible journey. Today, we're uncovering the most widely accepted explanation for the moon's formation, the giant impact hypothesis. A theory suggesting that billions of years ago, a cataclysmic collision between Earth and a Mars-sized planet, Theia, gave birth to our moon. So, what really happened? What evidence do we have? And how did this impact shape life as we know it? Let's find out. For thousands of years, civilizations around the world created fascinating myths to explain the moon's presence in our sky. In Greek mythology, the moon was Selene, a celestial goddess who rode her silver chariot across the heavens. In ancient China, legend spoke of Chang'e, a woman who drank an elixir of immortality and ascended to the moon. Norse mythology told of Mani, a divine being who guided the moon through the sky. But as science progressed, early theories emerged in an attempt to explain the moon's origin. First theory is the fission theory, and this theory suggested that the moon was once part of Earth but was torn away due to rapid rotation in our planet's early days. Second is the capture theory, and according to this idea, the moon was a wandering celestial body trapped by Earth's gravity as it passed by. Third is the co-formation theory. This hypothesis proposed that Earth and the moon formed together from the same disk of dust and gas billions of years ago. However, none of these theories fully explained the moon's unique characteristics. That's where the giant impact hypothesis changed everything. In the 1970s, scientists pieced together a groundbreaking idea, the giant impact hypothesis. It suggested that around 4.5 billion years ago, the young Earth collided with a Mars-sized planetary body, now known as Theia. The impact was cataclysmic. Theia struck Earth at tremendous speed, vaporizing rock and metal, and ejecting massive amounts of debris into space. Some of this material merged back with Earth, while the rest formed a swirling ring of molten rock and dust around our planet. Over time, gravity worked its magic. This debris gradually clumped together, cooling and solidifying into what we now call the moon. This theory not only explains why the moon and Earth share similar compositions, but also reveals a chaotic, violent chapter in our planet's early history. One that helped shape the world we live in today. But how do we know this actually happened? Let's examine the scientific evidence. The giant impact hypothesis isn't just speculation. It's supported by compelling scientific evidence. One of the strongest pieces of proof comes from Apollo mission samples. When astronauts brought back moon rocks, scientists discovered something remarkable. Their composition closely resembles Earth's outer layers. This suggests that the moon didn't form as an independent celestial body, but rather from material that once belonged to Earth. Another clue lies in the moon's unusual size. Compared to other moons in our solar system, Earth's moon is exceptionally large relative to its host planet. A massive impact like the one proposed in this hypothesis would explain why such a large satellite orbits Earth. Even more striking is the discovery that oxygen isotopes found in moon rocks are nearly identical to those on Earth. If the moon had formed elsewhere and was later captured by Earth's gravity, its chemical signature would likely be different. Instead, this similarity reinforces the idea that Earth and the moon share a common origin, one forged in a cataclysmic collision. The moon's lack of a dense iron core further supports this theory. Unlike Earth, which has a massive iron-rich center, the moon's core is significantly smaller. Scientists believe that when Theia struck Earth, the denser material remained behind, forming Earth's core, while the moon was primarily created from the lighter outer layers ejected into space. Modern computer simulations have also recreated this dramatic collision, showing that such an impact could produce a moon with characteristics matching what we see today. But while this theory is the most widely accepted, there are still unanswered questions about the details of this ancient cosmic event. Could there have been multiple impacts? And why does the moon so closely resemble Earth if a large portion of it came from Theia? The search for answers continues. The giant impact hypothesis is compelling, but it's not without its mysteries. One major question remains. If a large portion of the moon came from Theia, why does it resemble Earth so closely? Shouldn't we see traces of Theia's unique chemical signature? To explain this, some scientists suggest that Theia and Earth were already made of nearly identical materials before the collision. Others propose an alternative version of the impact hypothesis, where multiple smaller impacts over time contributed to the moon's formation. However, competing theories, such as the capture theory and co-formation theory, failed to explain the moon's composition, orbit, and lack of an iron core as effectively as the giant impact hypothesis. But regardless of how the moon formed, one thing is certain: our planet would be a very different place without it. The moon isn't just a passive satellite in our sky. It plays a crucial role in shaping Earth's environment. It stabilizes Earth's tilt, preventing wild shifts in climate. Without it, Earth's seasons would be chaotic and unpredictable. It controls the tides, which played a key role in the evolution of life, helping organisms transition from sea to land. It acts as a cosmic shield, absorbing many asteroid impacts that might have otherwise hit Earth. But what if Theia never collided with Earth? Imagine a world without the moon. No tides, no stable seasons, and perhaps no humans at all. Without the moon, Earth's axial tilt would be unstable, causing extreme climate changes that might have prevented complex life from evolving. Tides, driven by the moon, helped mix nutrients in early oceans, possibly playing a role in the origin of life. Without these tides, life's evolution may have taken a completely different path, or never happened at all. Would humans have even explored space without the moon to inspire curiosity? It's a fascinating question. The giant impact hypothesis provides the best explanation for the moon's formation, revealing a chaotic past that forever shaped Earth's destiny. Future missions, like NASA's Artemis program, may uncover new clues, helping us understand not just the moon, but how planetary systems evolve across the cosmos. Thank you for joining us on this journey through time and space. If you enjoyed this documentary, don't forget to like, share, and subscribe to Timeless Curiosity. Stay curious, keep exploring, and we'll see you in the next episode.